at the hardware school. So my starter project was to make a big time watch, and how this works is basically I press a button on the side and it displays the time. So from this project I learned a lot about soldering and the basic parts of a circuit. And then my main project was my hand gesture controlled robot with robotic arm. And so I'll give you a demo now. So as you can see, I can move my robot forwards, backwards, and turn it in 2 directions. As well, I've started working on my robotic claw, and I can make it move up and down. Unfortunately, my servo for the claw broke, so it's not able to open and close. But right now, it's able to move up and down. So how this project works is under the tape here. Under the tape, there's flex sensors, and when one of these is flexed, it will send a signal to the Arduino or my microcontroller. It's like a mini computer, and this Arduino will convert the signal into a text or a character, and send it from this XB, or my wireless communication device, to the XB on my robot, which is covered by my PCB board, but like all the wires. But so once this receives the character, it will convert that into a signal to either move the motors or move my arm. So another major part is this PCB board, and it holds all my connections and wires for my project. So the most challenging part for my project were the flex sensors. At first they were really unreliable, and they seemed to break a lot, but after some time I realized that they weren't actually breaking, it was just a bad connection in the breadboard. So I had to convert to using this PCB. It's just a different way of holding the wires, and this seemed to be a lot more reliable for me. My main modification was to add this robotic arm, and it was before earlier I was able to pick up a wallet and a ring of keys, but since this servo stopped working, it's not able to open and close, so it can't really pick anything up. So that was really cool, and now looking back at my experience at Bluestamp, I think that I learned a lot about programming and debugging, and I think that I've realized that I'm really interested in software engineering, and I want to further my knowledge in that. Thank you. Do you have any questions?
Yeah. What is the most important thing you think for your coding? Like, what kind of the thing you need to pay more attention?
I think lots of times I have, like, my project won't be working, and I'll be worried that I have a big error and I'll have to change a lot of things, but then I realize that it's just like a small part in my code. So I think that what I've learned is that it's the best way to do it, to find a problem in my code, is to just isolate the problem and like eliminate the things that like the issues that it can't be, and then I can find it. It's easier to find the right solution. Yeah.
How does a sensor work? The flex sensor?
The flex sensor? So what it does is it when it's flexed, it's sending readings constantly to the Arduino, and when this is constantly reading the readings, and when it's flexed, the readings go lower. And so what I did was I set a threshold, so when it goes below a certain point, it counts as a flex, and once it counts as a flex, it'll send a signal through the XB to this.
Why do you use row motors instead of DC motors to control your arm or any of the movement of arm?
What's the difference?
I think so. My DC motors, they're a lot heavier and they don't fit on my robotic arm. These fit really nicely, and also these were easier for me to control because on my DC motors, I could just turn it on and off. Versus on my servo, I was able to write specific positions to it, which allows me to not just go all the way to the top position or all the way to the bottom position. I was able to go to positions in between because it was, just on.
So one more question from that. If you use HPs or any other controller for your DC motor, you can make it work for like fraction of a second and make it stop, right? So it can move. So why do you use that controller and DC motor instead of servo for arm movement? What's the actual difference? You can study about that? It's like servo motors have like different angles that can move, like 5 degrees, 10 degrees, 15 degrees. They have internally built angles. So whatever angle you define, it's going to move that, it's going to stop. So yeah, this is an accuracy about the motors. You don't have with that DC motors. So that's why you use servo motors instead of DC motors.
What is the power supply you're using?
I'm using a 5-volt power supply. It's called the Anchor. So at first and for my motors, I'm using just a regular 9-volt battery.